Hello everyone, this is Mohammed Yaqub. I hope everyone is enjoying the start of the weekend. And it's time of the week again for another STM32 tutorial. And in today's tutorial, I'm going to share with you a library for the SSD1306 OLED display. And I've got a C++ library this time for it, written by my colleague Rohalla Jihad Al-Ikri as part of his STM training. And he's a rising talent in STM programming, so you expect more tutorials made by him, or perhaps more libraries made by him rather. Alright, so this OLED display uses R2C to communicate with the STM. So from the pinout point of view, all we need is an I2C interface, and you need to connect VCC to 3.3 volt and ground to ground. Alright, so I've got a library here that I will share with you down in the description of the video. So now let's just get started and set up a CubeMX project for it with the STM32F4 discovery board. On CubeMX, click on Access to Board Selector to select the right board. Right, I'm using the STM32F4 discovery board. F4 STM32F4 discovery board, and this one. And the first thing I'll do here on the pinout is that I'm going to clear all the pinouts and enable only the necessary one I need. So I'm going to enable all the LEDs on PD 12, 13, 14 and 15, and I'm also going to give them a label which will help me out in the programming so that I don't have to type the port and pin number. I can instead just use the label. So right click, enter label. I'm going to label them LED 1, 2, 3 and 4. Okay, so it's made by LED 2, and 3 is the red LED, and 4 is the blue LED. And I'm also going to enable my push button. It can come useful in demos, and I'll label it as a button. Okay, and now I just need to enable the connectivity R2C bus. So under connectivity tab, go to I2C1. You can use any I2C you want really, as long as you do the right connection and linking to the library. So on I2C1, select I2C mode. And this got mapped out to BB6 and BB7. So that's where we need to connect our LCD display I2C to. So you need to connect the clock to BB6 and data to PB7. Alright, and one more thing, I'd like to enable the external oscillator just so that I can have a very fast and very stable clock to the system. So under system core, go to RCC and enable the high speed clock and set it to ceramic resonator. And now let's go to clock configuration tab and configure the clock. So enable the external oscillator, and I know it's 8 MHz in frequency, and set the speed to 84 mega. And this will automatically adjust all the following clock trees. Right, okay, I'm also gonna lower this a little bit so that I get the maximum clock speed. Right, so that's everything for the configuration. So let's go to the project manager tab so that we generate our CubeMX project. The first thing we need to do here is to select the project path. I'd like to store it in this location in my OLED display folder, and I'm gonna call the project OLED /tutorial, and be very careful here when using Eclipse, when using System Workbench for STM32, because that's what we're going to use as an IDE. I'm not going to use Keil. I like to use this one when using C++, as it's got a very nice way of converting to C++ project. So when using System Workbench for STM32, it is very important not to put any spaces in the name, because the compiler can get you errors. So no spaces like this. Underscore is fine, but no spaces. Alright, so I'm just going to call it OLED /tutorial, and then select the IDE, System Workbench for STM32, and I'll leave everything else as default, I believe, apart from the firmware package. I don't want to use the latest one, just the 24.0 is okay. And that's it. So I'm ready to generate the project. So click on generate source code. Okay, and while this one is generating, for any of my business contacts, you can always get in touch with me through mutexembedded.com. Right, now project code generated successfully. For System Workbench, if you click on Open Projects, this might give you a Java error. So what you need to do instead is click on Open Folder, and this will take you to the folder location where the project is stored, and copy the folder path. And we're going to head manually to System Workbench and go to File, Open Projects from File System, and just copy the path here. And this will, and click on Finish, and this will add the project into your workspace. Okay, this can take a few seconds. Here we go. So this is your project, OLED/tutorial. Okay, so the first thing we need to do here is that we need to convert the project into C++ in order to use a C++ class into it, because you cannot use classes in C project. You have to convert the project into C++. But you can have the opposite. So you can use C libraries and C code in C++, but you cannot do the opposite. So to convert the project into C++, the first thing is to change the name of the main. So right click on main and click on rename, and it has to be main.cpp instead. Okay, and next on the tutorial folder here, right click and you'll find something called convert to C++. Click on this, and this will convert all the project into C++ so that I can enable classes and all the CPP functions. All right, so that's done now. Open the main. Here we go. So, and next, what I need to do is that I need to copy the library into my project. So here's the library that I'm going to include down in the description of the video, the H and CPP file, so that you can make use of them and use them in your projects. So what we need to do is that I need to copy this entire SSD1306 folder into my tutorial project, which is this one. And I'm going to just put the folder as a whole here. This will have the library's H and C file. And then on the project, I need to include those, the folder path and the folder source code. So when you click on F5 to refresh the directory, the folder will appear in here. But the folder hasn't got the C sign, so it's not part of the compile thing. And to make a part of it, right click on the project and scroll down to properties. And on here, you need to first add the path under GNU C++. I need to add the header path. And I know that the folder name is SSD1306. So just put the folder name because it automatically added on top of the project directory. All right. So this will add the include so that I can see the H file of the library. But I also need to add it as a source location. So on source location, add folder and add the SSD1306. This will tell the compiler that we've got C++ or C files into this folder, and click on apply and OK. And here we go. So there's a folder change, and now we can see the C sign on top of the folder, which means it's fully included as part of the compile. Okay, now let's open the library H and C file. And there's one thing we need to double check before we carry on, and that's the STM header. So this one uses the STM32F4 header, but if you use it with an F1, F3 or L0 STM board, all you have to do first is to change this STM header. And an easy way to do this is always your CubeMX automatically generated one, go to main.h, you'll find the STM header here. Just copy it and paste it to the OLED display library so that you can make use of it. All right, so that's the first thing. And now what we need to do is that we need to include the library header file that you will find it into the CPP folder, the CPP file. We need to copy this into our main so that we can start using the library. All right, and now as a first step, let me first compile the entire project just to make sure I've got no errors. So on the project, first right click and under index, do rebuild to do the indexing so that all these red arrows will go, because those are just part of the indexing thing. This can take a few seconds, and here we go. All of them have disappeared. Now let's compile the project before we carry on. All right, perfect. Project compiled without any errors. Now we can continue. And as with any C++ class or library, the first thing we need to do is to define the class object. And I know the name of the class is OLED. So I need to define an object for it, and we'll do that in the private variable into my main, the private variable public section here. So I'm going to call it OLED1. That's my OLED class object. And here in bigger number 2, after doing all the I2C initialization, first thing I'll do is that I'm going to check the I2C communication. So I want to see if the OLED display is connected correctly or not. An easy check for this is to use the HAL I2C library is device ready. So HAL I2C is device ready. And this function takes few parameters. The first one is the I2C handle, so HI2C1. This is defined by CubeMX because we selected I2C1. You'll find it at the top. Here we go. That's the one. And the second parameter is let me just go to the declaration of the function just to see all the parameters. The second parameter is the slave address of the OLED I2C display. And this is stored into the library. So I can use the library object OLED1 dot get address, get command address. And this will return me the expected address so that we can check it with the S device ready. And the third parameter is how many trials you want to try this. I'm just going to try it one time and then the timeout. Okay, and a timeout of 10 milliseconds is more than enough. And I'd like to check if this one returned me HAL OK, then I know that my I2C device is connecting and responsive to my test command here. So if this one is equal to HAL OK, then I know that my display is connected properly. Otherwise, you have to check your wiring or slave address perhaps. All right. If this one is equal to OK, I want to turn my LED on. So HAL GPIO right pin LED1, because I gave it a label, so it will appear in here, LED1 port, and then LED1 pin, and I write GPIO pin set to turn it on. Okay, so let's compile the project, load it to the board, and we're going to have a look at our LED. If it came on, then I know that my LCD is connected correctly, and I can carry on with the rest of the library functions. So, compiling the project. Okay, plug in your STM board, and let's load it to the board and make sure your LCD is connected correctly according to the CubeMX pinout and the VCC to 3 volt ground to ground. So loading it, select the AC6 STM run scheme. All right, so this is got loaded to the board, and let's have a look at the board. Perfect. We can see our green LED came on, which means that LCD is connected correctly to the I2C line, and now we can go ahead and continue with the library functions. All right. Second thing we need to do is to initialize the library and pass the I2C handle. You'll find a function called initialize here. That's the one. I need to call it into my main. So initialize the OLED library. And we need to use our class object. We call it OLED1.initialize. And this only takes the I2C handle so that the library knows we're using I2C1 and we can use it as a mean of communication. Okay, so we just need to copy this over and pass it as a pointer. And this will initialize the LCD. Now let's do some testing function. Now we can use directly, so test LCD functions. So perhaps first test is to fill display, and I want to fill it with either zeros or 1 because that's just an OLED display. So filling it with 0, use the OLED class OLED1.fill, and I want to fill it with zeros, so it's going to be black perhaps. And I need to draw that because when you do a fill, it's not going to fill it. You have to fill entire screen. So there's a function called let me go again to the H, draw full screen, because what the first function would do is that it's just gonna write to the temporary buffer, but it's not gonna show on the screen. So you need to always call the draw full screen, and this will fill it. And now put a delay of perhaps 2 seconds, and then fill it with ones so that it will all light up. All right. Now we'll do a similar scheme. So I need to do the fill with ones and then call in the draw full screen again. So let's compile it, load it to the board, and we're going to have a look at this. Awesome. You saw that on the LCD display. It first filled with zeros and then filled the entire LCD display with ones, so it all lights up. Next thing I'd like to test is perhaps just drawing some geometric shape maybe. So geometrical shapes. So I've got many functions here in the library written by RJA. So you can draw lines, circle, triangle. Let's start with the circle. And we've got two circle function, one that only draw a single pixel and one with line width. So let me just use the normal one. And this expect the X, Y, radius, and the color. Color is either 0 or 1. All right. So in our case, we're gonna use the 1. So OLED 1 dot circle. I'll use this one, and it takes the X, Y. So let's say in the middle of the display, which is 128 divided by 2 is about 60, because the display is 128 by 64 pixels. All right, so 60 by 30, and the radius of 20 maybe, and the color 1. Okay, and I'm first going to fill the LCD display with zeros before I carry on with that. I'll put that delay here so that it can do the first one too. So I'm going to fill it with zeros, do the circle, and draw full screen. Because all of these commands are implemented into the buffer, but not directly on the screen. In order for them to appear on the screen, you need to always call draw full screen. And there are two draw full screen functions. There is one without any parameters, and that's the one that's going to fill the user buffer, and the other one is to fill a certain custom one that I'll show you at the end. Okay, so that's it. So let me compile the project, load it to the board, and we're going to have a look at this geometrical shape testing. Brilliant. You saw that circle on the LCD display. But you may have noticed that the speed is very slow. In order to increase the speed, you can increase the I2C speed to from 100 kilohertz to 400 kilohertz. Okay, the next thing I'd like to show you very quickly perhaps is to print a text, to display print text. And you'll find many functions that you can experiment with and play around with. So let's do the text one. It takes X, Y string, the color, and the either is bold or normal, and then the size of text. So let's do that. So print text, we need to call in our class object OLED1.text, and we're going to draw this perhaps on 30 in X and I don't know, 25 in Y, and I'm going to print just hello. Okay, and the color is 1, so it's going to be ones, not zeros, so it will light up the specific pixels. It's not going to light them off. And then either bold or normal, just normal, and the size, well, say just 1 or maybe 2, just make them a little bit bigger. Okay, so I want to draw this on top of the circle, so I'm not going to do fill zeros. I'm going to do a draw full screen straight after the text. All right, so let's compile it, load it to the board, and check the printing text. Awesome, you saw the hello appeared on the screen. So that's amazing. So one last test that I would like to show you is how to print your own custom array to the display. So you have a 128 by 64 pixels array of ones and zeros that you want to print straight to the display without having to use our own libraries. And to do that, we use the draw full screen function, but the one with a 2D array parameter. So this one, so you give it a frame of 128 by 64, and it's going to draw this straight to the display, and that's a Boolean array of ones and zeros, whether you want to light up the pixels or light them off. Okay, so that's what I'm going to show you, and I'm going to draw an icon that I have in here. I've got my company logo, Mutex embedded. I'm going to draw to the display. Okay, so let me copy it over. And that's 128 by 64. So I'm going to put it in bigger number 0 here. And I copy the name of it. So it's called a Mutex frame. And so this one is custom frame. And we use the class object OLED1 dot draw full screen, but we're using the one with parameters, and we're going to pass this mutex frame. So mutex frame. So this will just draw it to the screen without anything. I'll put a delay here so that I can see these implemented, and then it will implement the draw the screen one. Draw the full screen with a frame. So let's compile it, load it to the board, and See the exciting bit, we should expect some very exciting logo on the screen. Brilliant, you saw the custom frame with the Mutex frame logo. Alright, I'll do one more exciting thing. I'm going to put this into the while loop and show you one more function that you can use, very useful one. So I'm drawing this logo. I want to do a toggle of the colors, so the on colors will become off and so on. So to do that, use a function called toggle, I believe. Invert, sorry, use a function called invert. Inverse display rather. So use the OLED class object, and it's called inverse display, and we give it 0 to inverse the display colors, and I'll put a delay of 1 second perhaps. So 1 to print with normal colors and 0 with inverted one. So I'll define a variable here, a Boolean variable. I'll call it my inverse, or rather my toggle. I'll set it to false initially, and then I'll pass it as a parameter to this with a hex. So in the first call, so it will be an XOR with 1. So on the first go it will be 0, and then it will be 1, and so on. So we'll see the logo toggling and changing, reversing colors. Well, in short, let me show you how it looks in the display. I'm sure you'll understand what I mean. So compile it, loading it to the board, and let's have a look at the LCD. Awesome, you saw that frame toggling on my OLED display. And this brings me to the end of my tutorial today. Thank you very much for watching, and I hope you found this OLED tutorial and OLED library helpful, and I hope you make use of it into your project. So thanks for watching, and if you found it helpful, don't forget to hit like and subscribe, and for any of my business contacts you can always get in touch with me through mutexembedded.com. Thank you, and I'll see you in the next video.